Hey guys, welcome to the second video of our Java concurrency series. If you haven't checked out the first video in which we covered the fundamentals, the code terminologies, then please do so. And in this video, we will cover the Java threads. We'll start the discussion on the Java threads. So let's get started. So first things first, let's discuss what is a Java thread. If you remember in the last video, we discussed what threads are in general and what does a thread represent actually. And we discussed that a thread is a unit of execution within a program or within a task or within a process, whatever you call it, that gets independently scheduled by the CPU, by the operating system. In the same way, when we talk about the Java threads, a Java thread is an independent unit within a Java program. So a Java program has multiple threads. A Java program can have many threads. And again, in the last video, whatever we discussed about the threads was about the native threads or operating system threads, because these are the threads which are executed by the CPU. These threads run in the kernel space. Generally, they run in the kernel space. So when we talk about the Java threads, a Java thread is a light wrapper around the operating system or native threads. We will cover this thing shortly. Now coming back to the Java threads, there are two types of Java threads, platform and virtual threads. Virtual thread is a new addition to the Java language, and before virtual threads, all the threads used to be platform threads. So if you don't create a virtual thread explicitly, by default, any thread that you create is a platform thread. We will cover platform threads and virtual threads in much more detail, probably in one of the future videos. And then we also have daemon and non-daemon threads. We will cover these one as well. So on a high level, a Java thread is a unit of execution within a Java program, which again is a wrapper around the native threads. And a Java thread can be a platform thread or a virtual thread. And additionally, it can also be a daemon thread and non-daemon threads. So let's move on. The next step is starting a thread. How do we actually create and start a Java thread? Well, there are three ways by which we can create and start a new thread in Java. The first one is using Runnable. Runnable is an interface, and we will see the demo of all these three shortly. So by using the Runnable interface, we can define a thread, we can start a thread. The second one is by using the thread class. There is a thread class in java.lang package that we can use to develop or to create new threads. And the third one is a new addition to the Java platform, which is using ThreadBuilder. So thread class now has something called ThreadBuilder, which follows the builder pattern. And by using this builder, we can easily create new threads, whether platform or virtual, daemon or non-daemon. Now let's talk about platform threads. Here we will only talk about platform threads. We will cover virtual threads in a separate video in one of the future videos. So what are platform threads? Platform threads are plain old Java threads. Virtual threads are actually a recent addition to Java language. Before that, there used to be a single category, which is platform threads. So old Java threads or non-virtual threads are by default platform threads. All right. And these platform threads or plain old Java threads are mapped one-to-one to kernel threads. Now, what are kernel threads? Kernel threads are basically threads created and managed by the operating system. So whenever we run a process, whenever we run an application, we know there will be multiple threads created by that application. So these threads that operating system creates are called kernel threads or native threads. So whenever we create a new Java thread, JVM with the help of operating system will always create a kernel or a native thread corresponding to that Java thread. And ultimately that native or kernel thread will be scheduled by the operating system and will be picked and executed by the CPU. So CPU or operating system does not schedule the Java thread directly, but it's always the kernel thread. So important thing to understand here is that when you create a non-virtual or the usual platform thread, there will always be a corresponding kernel thread that will be created by the operating system. All right. So for this series and demos, I will be mainly using OpenJDK21 because this is LTS as of now. And if you want to follow along, use at least JDK21 to avoid any problems, because it could happen some features are only compatible with JDK21. So I'm going to use OpenJDK21 LTS. Next, I will launch my IntelliJ and I will set up a fresh workspace in which we will see how to create and start new threads. So here I'm using IntelliJ. Feel free to use Eclipse or whatever IDE you are comfortable with. I'm using latest version of IntelliJ, which is available at the moment. And if you notice, this is a very simple project, although it's a Maven project, but there are no dependencies. It's a simple core Java project. So we don't need any external dependency for this demo. And I have set the compiler source and target to version 21 because, as I said, I will be using OpenJDK 21. All right. So next I will create a new package and will name it day 1. Although this is day 2, but there were no examples or demos for day 1. So we'll start with day 1. Okay. And in the day 1, let's create a new Java class and we can name it start thread. Because here we will see what are different ways by which we can create and start new threads in Java. All right. We will add one method, public static void main, because this is an individual class that we will run. So the first way of creating or starting a thread is by using the interface Runnable. So there are different ways of using Runnable interface. And let's start with the basic one. Suppose we have a separate class and we can name it Runnable thread. And this class will implement the Runnable interface. Okay. And this Runnable interface has a single method which is called run. Okay. So if we check out the Runnable interface, first of all, this is a functional interface. If you don't understand functional interface, please check out this video where I have explored and covered functional interfaces. Moving on. So this is a very simple interface which has a single method run. Any class which is implementing the Runnable interface has to implement or provide the implementation of run method. And this now represents your Runnable. And here you can write any logic that you want to run within the boundary of a thread. So let's say we are doing something like running a new thread using Runnable interface 1. Now a Runnable does not represent a thread in itself. It cannot start a new thread. To do that, we have to use something called thread class. All right, because this is the class which is responsible for creating and actually starting a new thread. So in order to do that, we need to create a new object of thread class. So we will say new thread. All right. And thread class has different constructors. And one of these constructors accepts the Runnable. So when we create the thread class, we can directly pass it a Runnable if we have a Runnable. Because we have the Runnable already, so what we can do, we can pass this Runnable to this thread, and now we have a thread object. So once we have the thread object, how do we start the thread? Well, it is as simple as calling the start method on the thread. All right. So in order to start a new thread, we need a thread object. Then to this thread object, we are passing the Runnable. And how are we creating this Runnable? We are creating this Runnable by having a class which is implementing the Runnable interface and by providing the implementation of run method. And then when we call the start method of that thread object, it will actually start a new thread. So let's quickly run this class and see what happens. So here if we check the output on the console, we see a simple message running a new thread using Runnable interface. We see the output, so it means that at least the code is working fine, but we don't know if a new thread was actually created. What exactly is different here? We won't see any difference in the output, and we won't see any indication of a new thread. But what is happening behind the scene is that when JVM executes this particular line, it will actually start a new Java thread. All right. And in this new Java thread, it will call the run method of this Runnable. So the new thread that was created will execute this piece of logic which is written in the run method. So if we write some other logic in the run method, maybe more complex logic, then that complex logic will be executed in a new thread. All right. So here we are creating a new thread using thread class and using Runnable interface, where we are implementing or creating a new class and implementing the Runnable interface. All right. So this is one way of doing things. The second way could be, because we know we have to create a thread object. So let's create another thread object like this. All right. And to start a new thread, we will call even.start. We need to call the start method. Now here's a very important thing. if you don't call start method on the thread, it will never create a new thread. All right. If you directly call the run method, it will simply execute the code within the same thread. I will explain this thing shortly, but you must call start method in order to create a new thread. Otherwise, JVM will never create a new thread. So to start a new thread, we must always call the start method on the thread object. All right. And we also know that we have to pass our enable. So instead of creating a class and implementing the runnable interface in this way, we know because runnable is a functional interface. So what we can do, we can provide the implementation using a Lambda function directly in the constructor here. All right. So in this Lambda function, we can again do something like a simple log message for now, like this, using Lambda runnable. And let's rerun the program again. And here we can see that the second thread was also created and executed by JVM because we see this message using Lambda runnable. So this is another way of using runnable by just providing the Lambda function. All right, this is method 1 and this is method 2. Now let's move on and cover another method, which is by using the thread class. So even though we are actually using the thread object or thread class, there is another way of creating a new thread, and that is by extending the thread class. So instead of implementing the runnable or passing the runnable as Lambda function, we can actually inherit from the thread class itself. So here we can have another class, let's say my thread, which can extend from the thread class like this. And then we can decide to override the run method. And similar to what we did with the runnable, we can provide a logic here in the run method because we are overriding the run method of the thread class. So let's copy the log message using thread class like this. And let me also add some loggers here. Like this. And this is method 2. And this is going to be method 3. All right. So once we have the myThread class, what we can do, we can use the class directly without needing to create the runnable. So what I mean by that is we can simply instantiate the myThread class here. myThread equals to myThread like this. And then we can simply call start method of the myThread. Now what will happen when JVM executes this line? It will actually call the overridden run method from here, from this class. Okay, so let's rerun. And here we see the third logger as well, running a new thread using thread class. Now observe, log messages are not in sequence. So we may expect that first we would see method 1, and then we will see the log message coming from this thread, then method 2, basically this log message, and then this log message coming from runnable Lambda, and in the end method 3 log message and the message coming from my thread. But if you notice here, these log messages are occurring before the log messages which are coming from corresponding threads. So this is our first hint that somewhere this execution is not sequential. All right, because otherwise we would see these log messages in a sequence, one after another. So that means there are parallel and independent executions. So I will cover the concept shortly, but before that, let's carry on with other methods as well. So far we have covered using Runnable and by using thread class, and there is one more which is by using ThreadBuilder. So let's move on. So let me copy this bit. Although we know this is not going to work as expected, but still this is going to be method 4. All right. How do we access this thread builder? Well, this thread builder exists in the thread class itself. So we can do something like we can use the same thread class dot, and then it has different methods like off platform, off virtual. So with the help of this builder, we can actually create platform thread or virtual thread by using the corresponding off method, which is the static method. Right now, since we are only focusing on platform threads, so we will create a new platform thread by using off platform. This will now create a platform thread. Now, what else can we define here? We can provide it a name. So let's give it a name. Till now, we have not given the name to any thread, but here we can define the name. So we can call it ThreadBuilder thread. All right. What else? We can define if this is going to be a daemon or non-daemon, but because we have not covered daemon threads, so let's not use this property as of now. And then we can pass the runnable in a single line by calling the start method on the builder, which accepts a runnable. So if we use this method, we need to pass the runnable, and we know we can pass the runnable by using the Lambda function. So within a single line, you see we are able to create a new thread. We are able to provide all the details using this builder. And in the same way, let's put a logger here. And we can say running a new thread using ThreadBuilder. Now this time, if we run the program, you see we are getting this log message running a new thread using ThreadBuilder. Now observe, in this case, we are not calling the start method in the same way as we were doing here. But instead, we are calling this start and passing it runnable here at the same line. So this will not only define the thread, but it will actually start a new thread. All right. But let's say we simply want to create the thread object and want to start it at a later point of time. That is also doable. So all we need to do is I can copy this one and we can give it a different name like this. And then it has a method unstarted. So let's pass it the runnable and unstarted. Now what this will do, it will create a new thread with this name. It has this runnable, but it is not started by default. We have to start it explicitly. To do that, we need to save the reference like this. All right, T2, it is T2. And then same as before, we can call the start method whenever we want. So this will now start a new thread. You see ThreadBuilder unstarted. So these are the main 4 ways by which we can create and start Java threads. So by using Runnable, we can either pass the Runnable directly as Lambda, or we can create a class and implement the Runnable interface. The other way is to use the thread class directly, inherit the thread class and by overriding the run method. And then we have different ways to create a thread by using the thread builder. All right. So we can use off method to create either a platform thread or a virtual thread. Then we can start it by default as we are writing it, or we can put it in the unstarted mode and then start it later. All right, as per the requirement. Okay, now that we have seen threads in action, let's learn how JVM runs a thread. What happens when we call the start method on the thread object? What actually happens when we start a new thread? So in the last video where we were covering the fundamentals, we learned what happens when we execute a new process. We learned about the data structures like PCB, TCB, and process table and thread table. Now, when we discuss about Java threads, this is going to link up very nicely. So let's quickly go back to the IntelliJ where we saw the threads in action, and we'll start from there. So here we saw how to start a new thread. We create the thread object and then we call the start method on the thread object to actually start a new thread. Now, when we call the start method, if we check the implementation of start method, which is coming from OpenJDK, so we see a synchronize block here. We haven't covered anything related to synchronization, so we don't need to worry about it as of now. You can think it like this code will be executed by one thread at a time. So thread initialization part is synchronized, I mean thread safe. We need to focus on this line where start method calls another method which is start 0. And what is this start 0? This is a native method. And we know in Java, native methods don't have the Java implementation. The implementation is generally given in low-level languages like C and C++. So implementation of this native method exists somewhere in JVM because this is a native method, right? So when we start a new thread, when we call the start method, JVM calls the native method start 0. So let's go back to the whiteboard. What happens when we call the start method on the thread? Internally, it calls start 0 method, which is a native method. Now the implementation of this method will be given in the JVM. So for example, let's say if we are using Amazon Corretto, then that JVM is responsible for implementing start 0 method. And similarly, let's say if we are using hotspot JVM, then hotspot JVM would have the implementation of start 0 because this is a native method. Then what happens internally, there is another method which is called, and that method is known as JVM underscore start thread. Now these are not Java methods, these are not coming directly from JDK, but now we are talking about JVM. So JVM internally calls this method which is JVM underscore start thread. And now this method is responsible for creating a new native or operating system level thread. And how it does that? So we know we can compile the Java code once by using Java compiler, which generates the bytecode. And then in order to run the bytecode on different operating systems, we need the corresponding virtual machines or JVMs specific to those operating systems. So the JVM on the Windows machine will be different from the JVM which is running on a Linux environment, for example. So this method now executes operating system specific code, all right, in order to create a native thread. Because how native threads are created is highly dependent on the operating system. Windows has its own way to create threads and Linux will have its own way. And they will have their own native set of libraries to create threads. Alright. So the responsibility of this method JVM start thread is to work with the operating system specific code to use the operating system specific library in order to create the native thread. And this native thread is also called operating system level thread or kernel thread, as we covered in the previous video. Alright, so once we have the native thread, this native thread will be scheduled by the operating system thread scheduler. Okay, and once we have the native thread, we know how operating system schedules or manages the kernel threads or native threads, because we have covered this already. So this is linked here as we discussed. When we have the new thread which has been created for the Java thread, the operating system create a new thread block for the newly created thread, and it will also update the thread table with its corresponding thread ID. And we know this thread control block will have its own metadata related to the newly created native thread. So now we have the native thread which will be scheduled by the operating system and will be executed on one of the CPU cores. But what exactly will it run? So what happens, whatever implementation we have given in the run method on the Java side when we define the Java thread, all right? So whatever implementation we have given here, what JVM will do, it will wrap this up and pass it to the native thread. So you can consider it as a bundled code. Although this is in the bytecode, but this code will be bundled as a wrapper function and will be passed to the native thread. So whenever native thread gets the chance to execute on the CPU, it will actually execute this piece of code. So that's how JVM creates a new thread, and whatever we have given in the run method is executed by the native thread. Because ultimately it's the native thread that will be executed by the operating system, not the Java thread. They are linked, they are one-to-one mapped, as we covered in one of the previous slides. So we will continue our discussion on Java threads. I will see you in the next video, which will be about Java thread lifecycle. So see you in that video. Thanks for watching.